Okay, let's start with 11.6, similar triangles, page 616 in your book. What is a similar triangle? It's two triangles that have the same shape, but not necessarily the same size. The corresponding angles of the two similar triangles are congruent. This squiggly line right here, a single squiggly line, is the shortcut for writing similar. And that's the congruent sign, equal to, and the squiggly line above it. The corresponding sides of two similar triangles are also proportional. And when I say proportional, I mean they have the same ratio, and you'll see that here in this example right now. Suppose I have two triangles, and I want to just investigate these two triangles and look at them. I notice right away that A, B, C, and D, E, F are kind of the same size, shape, okay? But definitely this one is bigger than this one. This one is smaller. But I then look at the angles. Well, 83 degrees, 83 degrees, 56, 56, and the bottom right, 41 and 41. So all the angles are the same. So it must be similar triangles. And then when we look at the sides will be proportional. Let's take a look at that. Here's the corresponding angles. A and C is 56, B and E is 83, C and F is 41. We just looked at that. Now let's look at the sides. Well, AB is corresponding to DE. Okay? So AB and DE are corresponding sides. So if I set up a ratio, put the AB on the top and DE on the bottom, I get a 2. The length of AB over 4, the length of DE. And that reduces down to 1/2. If I then look at the next side, BC and EF, I get 2.5 over 5. 2.5 over 5 reduces down to 1/2. And finally, looking at the bottoms, 3 and 6, 3 over 6 reduces down to 1/2. So in a similar triangle, all the angles that are corresponding are equal, and each of the sides, when set up as a proportion, come out to be the same. All right? Let's look at an example or a problem. What if I was given these two triangles right here, right there? These two triangles. I've given those two triangles. Are these triangles similar? Remember, this is the symbol for similar. Okay? Well, for them to be similar, I need to have all the angles, corresponding angles, be the same. So I'm going to look at it. What is my given? I've got two that are equal here and one number here, so I can figure out those two. And I can figure out, I've got two, missing one. I'm going to figure this one out first. Well, P is equal to what? Well, I know two angles, so I know that a triangle has 180 degrees total. And I'm going to subtract 51 and another 51. And what do I end up with? I end up with 78. So angle P right here is 78. Well, that corresponds with an M. Notice I have to rotate this one around to be the same size. That P and M are the corresponding angles. Okay, so now I got to find out if N and O are equal to R and Q. Well, angle N and angle O are both equal to 1/2, because they're the same, of 180, the full triangle, minus the 78. 180 minus 78 is 102. 102 divided by 2 is equal to 51. So I've now proven that N and O are 51 degrees, which matches down here, and 78, P, matches M, and so all my corresponding angles are congruent, are equal, thus these triangles are similar. All right. What if we want asked to find unknown measures in a triangle? So this is example 2 in your book. Let's say I'm given two triangles, and they're similar. One's a little bigger than the other. There's my two triangles, and we know that they're similar. And this one is TUV, and this one is, the second one is WXY. And the other things we're given is that this is 47 degrees, and this is 47 degrees. This is 98, and this is 98. This is 3, 4, and 6. And over here we have an unknown A, and an unknown B, and 16. And we're asked to solve the triangle. Well, when you solve a triangle, you have to figure out whether or not all the unknown pieces. Well, the unknown pieces here are this angle and the values A and B, the sides of the larger triangle. Okay? Well, right away, we can figure out that this angle Y and angle B, angle Y and angle V are equal to 180 minus the two angles we have, 98 and 47, which gives us a final answer of 51. So 47 plus 51 is 90. That doesn't come out right, does it?